over to the next one, that is depth first search. Now, how does the depth first search work? The depth first search starts from the beginning, which of course our case we are calling the departure state. It moves from one end of the tree until it gets to the destination that it's looking out for. So, say for example, we are looking for Sokoto again using the depth first search method. Now, let's say we're sending from Enugu. Enugu has 2 children, and if you notice here, the first child is Lagos. So in the graph here, it will follow the route of Lagos. So Enugu to Lagos. Remember, we're looking for Sokoto. And then under Lagos is connected to 2 ends like that. Where is that? Yeah, Lagos is connected to Enugu and Ogun. So it continues going down one lane. Now, notice that we didn't go through Lagos and Niger first. We went through Lagos, and then we're checking for states connected to Lagos, and then we'll follow one end. Again, we'll pass through maybe Ogun this time around, and then check for states connected to Ogun. Now, if Abia is the first state, we move straight through Abia to the next state connected to it, which is Ebonyi, and continues like that until we find Sokoto. So that's what we want to write out programmatically this time around. So let's do that. Depth first search. We'll take 3 parameters this time around. The departure states. So I'll spell that correctly. Departure, okay. States. The destination states. And then we'll have our visited set outside here. Yes, we're creating it here. Let's move this a little bit inside. Okay, yeah, this is good. It should be visited. All right. So we're creating the visited set here. As you continue, you will gradually understand why. But basically, we are creating or putting it as part of the parameters because we are going to use a recursive approach to handle this. And so every time we are doing it or going through the recursive approach, we'll be passing the already visited items into the parameter or the arguments that we'll be passing down here. If not, we'll run into an infinite loop. All right, so let's continue. But the first thing we will do is to get the destinations of the departure states. So, sorry, we'll start const destination destinations, okay, connections dot get departure states. That's what we need, departure states. So this gives us access to the departure state. All right. Then since we are visiting the departure state already, we need to add it here. Visited dot add it to the departure state. Departure. Okay. If we don't add the departure state to the visited, then we will definitely run into an infinite loop because we won't be able to keep track of these items. All right. So let's now loop through. We'll use a for off loop. We are now looping through the destinations. So for destination of destinations, I assume this is similar to what we've done before, so I assume that this will not be so difficult for you to grasp. So what we want to do here is what we've done before. We want to check if the destination we are currently on is the destination state that we're looking for. So just like before, if destination, that's this destination we are currently on, is equivalent to the destination state. All right. Let's log to the console.log and say depth first search found the destination states. Okay. All right. Now, after checking this destination, we also want to check if it's already part of the visited items. So if not visited, so basically if we have not checked other items connected to it, so not visited dot has the destination, then what do? If it's not part of the destination, then we are now calling this function again, and that's where recursion comes in. Depth first search. Good. Now, instead of passing the departure state as the first item, we're passing the destination because now we want to check this new node that we are currently on. So we're passing destination, then the destination states will remain the same. And this time around, we are passing in the visited without setting it to a new set because we want to still keep track of items that we visited. And that is it. That is all you need to do a depth first search algorithm on this graph. And let me walk you through again what is going on here. This depth first search function takes in the departure state, a destination state, and a visited set. Of course, it is a new set here. All right. Then, in order for us to loop through or move or transverse through the graph, we need to get the destination first of the first node, that is the departure state. And that's what we did here. We got the destinations. now that we have the destination, we pass in this departure state into the visited, so that we keep track of items that we visited, so that we don't come back to visit it again. Then we come down here, and then we are now looping through these destinations that we've just received. If the destination that we are currently on is the destination state, then we just write out to the console DFS found destination state. And we'll also check if this item or this state has not been visited before, then that means we need to search through it. So what do? We call on the def first search function again. But this time around, instead of passing the initial departure state, we are passing in a destination. That's the destination that we are currently on while looping. We're passing the destination state because that is what we are looking for. And then we're passing the visited. But this time around, we're not setting it to a new set. It is the visited set that we already have, basically keeping track of this state that we've been able to visit. A depth first search algorithm uses stack. Stack is more like the opposite of a queue. What it does is it follows a rule called last in first out procedure. What it does is, as it loops through and searches down the down the graph, when it's done with a particular maybe a particular side of the graph, it comes back or returns gradually. As it returns, it keeps checking other nodes that are along the way where it's coming back from. Or basically, it starts from where it stops and comes back gradually. It has just one end, and so the same end where it puts in items is this end where it removes items from. So at this point, we can now test the depth first search algorithm that we just written. Depth first search, and we're using the same value here, so let's just copy this. Sorry. All right, let's get rid of this. Cool. So let's run the search. Beautiful. Notice here, depth first search found twice Sokoto again using the depth first search algorithm. Beautiful. It shows that this is working, and on your own you could just break down this code, maybe try to read through the code just in case it's not very clear as you would expect it to be. Read through the code and add a few console logs at different points and see what's going on at different points of the program. If you do it that way, then you gradually get more understanding and everything becomes clearer with time. If you are new to graphs and algorithms, data structures, then this is a very good place to be, because what we've done is what you meet in many technical interviews. So I want you to take your time and check this out. You don't have to get discouraged if what you are doing is not working at the moment. Once you keep practicing, it gets clearer. So thank you for watching. Please, you do well to like and subscribe. Of course, you can follow me on social media. And that is it. I'll see you in the next tutorial.